let's take a look at another example. We're going to look at a function known as the Dirichlet function. We're going to see, does the limit of this particular function, does it exist for any choice of c? We can also think about, what does this tell us about continuity for this function? Right? But this function, the Dirichlet function, it is defined in this way. So f is this function with a domain of the real numbers and codomain of the real numbers. F of x is defined to be equal to 0 if x is a rational number. F of x is defined to be 1 if x is an irrational number. Right? And so we want to know, does this limit, does the limit at c, does that exist? Does the limit of f at c exist for any choice of c at all? All right, so let's start here. Let c be a real number. Then for epsilon less than 1/2 and any choice of delta, that's greater than 0, what's going to be true? Well, there exist both rational and irrational numbers. There exist both rational and irrational numbers x such that the distance between x and whatever this value c is up here, the distance between x and c is less than delta, right? So no matter what choice we might choose for delta, there's always going to be an infinite number of values within an infinite number of rational and irrational numbers within delta units of c. So what does that tell us? So the absolute value of f of x minus L, if there is this limit, that would be L minus 1 if x is rational, and it's going to be L if x is irrational. But if the absolute value of L minus 1 is less than epsilon, and the absolute value of L is also less than epsilon, right? Because we know that there's both rational and irrational numbers within delta units, and so we need to have kind of both of these values as outputs. If the absolute value of L minus 1 is less than epsilon and the absolute value of L is less than epsilon, then this would imply that 1 minus epsilon is less than L, is less than 1 plus epsilon. And we would also have negative epsilon is less than L, is less than epsilon. What did we say about our choice of epsilon, though? Well, we chose epsilon here so that it was less than 1/2. And so when we choose epsilon so that it's less than 1/2, what that's going to do for us here is that's going to force this lower bound here to be, tell us that our choice of L here has to be more than 1/2. And over here, it says this value L would also have to be less than 1/2. Right? And so that's where we're going to get a contradiction. So since epsilon is less than 1/2, this is a contradiction. Thus, the limit of f of x at c does not exist for any real number c in R. And then what can we say about continuity? F of x is not continuous at any real number. Nice. So that is our second example here. We can show that the Dirichlet function, Dirichlet function, it does not have a limit. The limit does not exist for any choice of c, and so the Dirichlet function is actually not continuous at any real number. We'll have one more video in this section where we're going to look at just a couple more theorems related to continuity. And I will talk to you and see you guys then.